Hi, welcome back to Intermediate Algebra. Today we're looking at section 7.3, just some additional stuff, some additional items as we look at solving quadratic equations. So we're just going to hit a couple of topics here. There's nothing huge in this section, but there's definitely some stuff you should still know here. First thing is the discriminant. The discriminant is just the part that is underneath the square root in the quadratic formula. So it is b squared minus 4ac. Basically, the discriminant tells us how many solutions we get and what they look like, what kinds of numbers they actually end up being. And so, this is something we can do. If the discriminant ends up negative, you get two complex solutions. If it is 0, you get one rational solution. If it's a positive perfect square, you get two rational solutions. And if it's a positive but not perfect square, you get two irrational solutions. So just a couple of reminders here. Complex numbers are going to have I in them. A rational number is anything that could be written as a fraction, so you won't get anything truly hideous with these two middle cases. And the third kind, irrational numbers, are things like pi, numbers that go on forever, or the square root of 2, which is actually something that could show up here. So those are the possibilities, and really it's just a quick way to tell what are your solutions going to look like. So I have an example. We'll do one more on the next board too. It says how many solutions and what kind are they? And so we have the equation 3x squared plus 2x minus 5 is equal to 0. Well, all I have to do is plug it into the discriminant. I don't even have to worry about the square root or any of the rest of the quadratic formula, just the b squared minus 4ac. So I plug in my numbers. 2 squared minus 4 times 3 times negative 5. If you clean that up, 2 squared is 4, 4 times 3 is 12, times negative 5 would be negative 60, but with the minus sign in front, makes it a plus 60. So we get 64, which is a perfect square. And from back here, we have a positive number that is a perfect square, so we know that we have two rational solutions. Now, one word of caution here, because sometimes this happens. When you plug numbers in, it's really good, since we have multiplication here from the 4ac, that you use those parentheses so you remember that that's what you're doing. Sometimes people leave those out, and I end up with a subtract 5 there, and then answers end up really wrong. So just be careful with your order of operations and with how you write things, so that you can, so you don't make silly mistakes just because you wrote it down wrong. So anyway, let's get this board cleared off and do another example on the next board. All right, so our next problem says find k such that 3x squared minus kx equals negative 3 has one rational solution. So the first thing I did is I moved that negative 3 over to the other side because we need this to be in its standard quadratic form with 0 on one side. Just like when we use the quadratic formula, we can't do the discriminant without 0. So you're probably thinking, but wait a second, you threw this weird letter k in there and that's what you're asking me to find. You're not just asking me to find a discriminant. Nope, we're actually asking you to apply what you know about a discriminant. In this case, we know that the only way you get one rational solution, if you remember from that last board, is if the discriminant is equal to 0. So I'm going to set up my discriminant, it's right behind me here. I'm going to set it equal to 0, and then I can solve to find k. So let's see what I did. All right, so we have b squared minus 4ac is equal to negative k, and I'm going to square that. Now notice when you square negative, you do get a positive, so I can just drop that negative out. Minus 4 times a is 3, c is 3, so we get k squared minus 36 is equal to 0. Now I cheat a little bit here, not a whole lot, just a teeny little bit. I'm just going to add that 36 to both sides because since there is no middle term, I can just solve this by taking a square root, which is going to be much nicer than completing the square or the quadratic formula. So I add the 36, giving me k squared equals 36. I take the square root of both sides, get rid of that square, and I don't forget that when you take a square root to solve an equation, you do get a plus or minus. So there are two potential values here for k that would make this work. Either positive or negative 6 will supply us with just one rational solution. So that's exactly what we want. All right, so now we're going to go on to the next board. We're going to look at how we can build equations if we already know the zeros. So let me get that set up. All right, on this board, we're going to lay out everything we need to start building equations, and then on the next board, we'll start doing some examples. So building equations, we're going to start with the solutions instead. So we're going to make an equation where it has all the zeros that we want it to because we're making it that way. To do that, we start with the solutions, and then we're going to turn it around and we're going to set them equal to 0 instead. And I'll show you what I mean when we get to the examples. Then we're going to multiply the factors and finally set the whole thing equal to 0 so that we have an equation. All right, so and I'll kind of talk through some of this a little bit more when we get into the examples. But before we do, I have one other thing I need to talk about. And it's this thing called multiplicity, because it comes into play here a little bit. Multiplicity basically means that you have repeated zeros. Zeros that happen more than once in an equation. And that's a little bit weird, and so I guess it's a bit of a philosophical question. Can you really have more than one of the same zero? Anyway, so we have x plus 3 squared is equal to 0. I'm just giving an example here to show some multiplicity. This is an equation that's going to have two zeros, and they're going to be the same thing. And so we can see that it really has two zeros if we think about the x plus 3 squared as being x plus 3 times itself. Now, this is in factored form. It's set equal to 0, so we are allowed to split it apart and set each piece equal to 0. And so when we do that, we get x is equal to -3 for both of them because they're exactly the same. And so we can say then that -3 is a 0 of multiplicity 2. Now this becomes a more important concept a little bit later in algebra, but it's something that's certainly worth introducing here. And so again, this is where you kind of get into the weird philosophical bit. Are these two zeros? Are they really just one because they're the same thing? And I come down on the side that they are definitely two zeros. And I think most mathematicians would. But you know, if you're like Mr. Sandler, let's do the same thing. Yeah, okay, I get that too. So anyway, that's multiplicity, and that's going to play into our second example that we do when we build equations. So let's start those examples. All right, so here we have my first example for building an equation. If x equal to 4 and x equal to -½ are solutions, what is a possible equation? Now, notice I didn't say what is the only equation or something like that, because it actually turns out there are a lot of equations that would have these two numbers as solutions. In fact, really, there's an infinite number, and we just want one. So let's just find one. Easiest way to do this. So you start with the zeros, or with the solutions, 4 and -½, and well, let me erase that for just a second so we can see this better. And we're just going to get 0 for both of them. So for the first one, that's pretty straightforward. X is equal to 4. I just go ahead and subtract 4 from both sides so that I have 0. This gives me a linear factor, and that's going to be one of the building blocks then for our equation. I'm going to steal that x minus 4 here in just a second. In fact, you can see it up over there. For the second one, I have a fraction. And honestly, the next step is going to be easier if we don't have any fractions running around. So the very first thing I did here was I multiplied both sides by that denominator, the 2. Because what that does then is it eliminates the fraction, and now I have 2x is equal to -1. I can add the 1 to get my other linear factor, 2x plus 1. Okay, so now I have two pieces, two factored little linear pieces, and they're both equal to 0. Hey, that's kind of nice, because now I can multiply them together and leave them set equal to 0. Because if I do that now, this is an equation that will have 4 and -½ as solutions, right? If you plug, it's easiest to see with the 4, but if you plug in 4 here, 4 minus 4 is 0, and 0 times anything is 0. There we go. There's an equation that's going to work. I don't want the parentheses, so I go ahead and multiply it out. X times 2x is 2x squared. X times 1 is x. Minus 4 times 2x is minus 8x, and minus 4 times 1 is minus 4. Clean up the mess a little bit, you get 2x squared minus 7x minus 4. Don't forget to leave it equal to 0. If you don't have it equal to something, and really it needs to be 0, then you don't even have an equation. So we do actually want to have an equation here. All right, so I'm going to do one more example, and this one's going to have a little bit of multiplicity in it, and that'll be fun. All right, so here's my other example. This one has some multiplicity in it. It's just going to be a little bit bigger and messier problem. Same process, so that's good. All right, it says if x equal to 3 is a 0 of multiplicity 2 and x equal to 1 is a third 0, find an equation with these solutions. So I wrote out my solutions. Notice I wrote out x equals to 3 twice. Really, you can just do it once as long as you remember to use 2 of them over here. So I have x equal to 3, x equal to 3, and x equal to 1, and I got them all equal to 0 by subtracting. Okay, so now I have my 3 pieces, x minus 3, x minus 3, and x minus 1. And this is important because we need 3 to be a 0 2 times, not just once. So I write it out as a multiplication problem set equal to 0. And then I start multiplying. So I kind of skipped a little bit of the work on the board here. I did x minus 3 times itself and got x squared minus 6x plus 9. You're welcome to multiply that out and check my work. That's usually a good idea. And then I multiplied it by x minus 1. So you can follow through here. X squared times x is x cubed. X squared times minus 1 is a minus x squared. Minus 6x times x is minus 6x squared. Minus 6x times minus 1 is plus 6x. 9 times x is 9x. 9 times negative 1 is negative 9. And then I combined my like terms. Negative x squared, negative 6x squared give me that minus 7x squared. And 6x and 9x make 15x. And there we go. That's really this section. So good luck. You're going to be building equations and using the discriminant. Loads of fun. Have a good day.